So for problems 40 to 51, you may want to use your calculator for these problems. So some of them have to do with natural logs and some of them have just more logarithmic questions here. So let me go with question number 40 here. So it states that e to the power of 2x plus 3 is equal to 37. And so the best way here again would be to say that 2x plus 3 is some variable. We don't know what it is, so we could say that 2x plus 3 is equal to z. So we just say that let 2x plus 3 be equal to z here. So obviously we can then say e to the power of z is equal to 37. And if you recall from my previous lessons, you can really use that concept of a logarithm, right? So we can say that log, again, we know that e here is the base. Therefore, log base e of 37 is equal to z. Remember, it's always you have your exponent here, e to the power of z, right? So your exponent here is z. Your base here is e, so we say that whatever the base is, you write that as log base e, right? This is base e of 37, right? Of this term over here is equal to the exponent is equal to z in this case. And so really log base e of 37 is ln of 37, and you have that function. You have that function on your calculator, so that is equal to z. And so you can evaluate the value. For z, and then plug that value back into this equation, really, because you know that z is equal to 2x plus 3. So once you get ln of 37 is equal to z, you're just going to do z, whatever value you get for z, minus 3 divided by 2 to determine the value of x. So in this case, once you plug in the values into your calculator, you should get the value of x being 0.305 rounded to 3 decimal places. So that's question number 40 here. So x is equal to 0.305. So let's do 41. So question number 41, right, states that e to the power of 2x minus 5 times e to the power of x plus 6 is equal to 0. And similarly, you may not see it at first, but really we can put this into quadratic form, right? Really, if you say that e to the power of x is z, right? Well, then you can say that e to the power of 2x is z squared, right? And again, the reason is z times z here would be just e to the power of x times e to the power x. They have the same base. Well, if you have the same base, according to the exponential rule here, if you have the same bases and you're multiplying these two, right, you can add the exponent. So you have e to the power of x plus x, right, because you're multiplying exponents with the same base here. So e to the power of x plus x, well, that's just e to the power of 2x, right? So that's just to show you that here e to the power of 2x can be written as z squared, and so we have minus 5z plus 6 is equal to 0. You want to look for two numbers that have a product of 6 and a sum of negative 5. Well, that's easy. That's just z minus 3 times z minus 2, right? As negative 3 and negative 2 have a product of 6 and a sum of negative 5. So that is equal to 0. And so obviously z here is e to the power of x. So you can substitute that back into the equation. So e to the power of x minus 3 times e to the power of x minus 2 is equal to 0. And you can set each factor to 0. So you see that e to the power of x is equal to 3, e to the power of x is equal to 2. So you have these two equations over here, right? And really, again, when we're talking about this, we want to put this into the logarithmic form here to solve for x, right? So we say that log base e, right? Because e is your base. Your base e of 3 is equal to x. X is your exponent here. Similarly, log base e of 2 is equal to x. And so when you say log base e of 3, well, that's just ln of 3. Log base e of 2, well, that's just ln of 2. So ln of 3 and ln of 2 are two possible values for x. So you see that evaluating ln of 3 right on your calculator, you should get something like 1.10, and then ln of 2 is equal to 0.6 0.693. So your final two solutions here to this problem are 1.10 and 0.693. So those are questions 40 and 41. So thanks for watching.